Hello, let us look at the questions in mechanical engineering from the subject of mechanical paper, mechanics paper for forenoon session. Two questions have appeared. Let us look at the first question. The question says, consider a 2 degree of freedom system as shown in the figure where PQ is a rigid uniform rod of length B and mass M. Of length B, there should be a comma over here, of mass M. Okay, so you're having a spring over here, there is a block of mass capital M, and this rod over here PQ is having a length B and mass M. Assume that the spring deflects only horizontally and the force F is applied horizontally at Q. For this system, the Lagrangian L, again a comma should come over here, a Lagrangian L is equal to how much? He has given you some 4 options. Okay, forget about the options. Let us solve first of all to get the answer. Now, first of all, what is the concept of Lagrangian? The value of Lagrangian happens to be equal to, it is equal to kinetic energy of the system minus potential energy of the system. Kinetic energy minus potential energy. Now, you have to ask yourself that what all kinetic energies am I going to have and what all potential energies I'm going to have. So, you should know that there are going to be 2 kinetic energies. There are going to be 2 kinetic energies. The first kinetic energy is for this particular block. So, kinetic energy of mass capital M is going to be there. Apart from that, you are going to have kinetic energy for the rod. You are going to have kinetic energy for the rod. Next, potential energies. Again, you are going to have 2 potential energies. 2 potential energies. One potential energy is going to be the potential energy of spring. Potential energy of spring, and the other is potential energy of rod. Potential energy of rod. Now, let me tell you that this question is not as simple. It is slightly complex question, and rod, the concept of rod over here makes it difficult. But I'll try to simplify it as much as possible. But the simple concepts over here are kinetic energy of mass M and potential energy of the spring. Even this potential energy of rod also is very simple. This is slightly difficult. The kinetic energy of rod is slightly difficult. So let me do one thing. Let me establish some concepts. Okay. First, I'm going to talk about kinetic energy of mass, then potential energy of spring, then potential energy of rod. Let us say kinetic energy of mass. Now, this will be equal to how much? It is going to be equal to half m into v square. Now, velocity of this mass is purely in x-axis. Therefore, it has to be equal to how much? It has to be equal to half m into x dot square. Half m into x dot square. Okay. This is done with. Let us go for potential energy of the spring. Potential energy of the spring is equal to how much? Potential energy of the spring is equal to how much? It is equal to half kx square. This is something, okay, whenever you're having a linear spring, that time you're going to have half kx square. Very simple. Finally, what about the potential energy of the rod? Potential energy of the rod, if I take this as my reference, I'm going to have first of all a negative potential energy. Second thing, since I'm having a uniform load, it's not a point load, it is a distributed load, I'm going to have the potential energy of rod is equal to, okay, first of all I'm going to have a negative. Since it is a uniformly distributed load, I'm going to have m into g into length of rod by 2 into cos theta. Now, length of rod is equal to b, therefore this has to be equal to minus mgb cos theta divided by minus mgb cos theta divided by 2. These 3 things are done with. Now comes the point of kinetic energy of rod. This is difficult. To understand this, I want you to imagine, take your time, please pause the video wherever it is required. Okay, this can become critical. To understand this kinetic energy of the rod, I want you to take a very small element over here. A very small element, let us say, along the rod. This element I am choosing at some distance, let us say, the distance, let us say over here. For the sake of easiness, let us consider the distance as y. Suppose this length over here of this element is equal to dy. It is equal to dy. Now, what all velocities is this element going to experience? First of all, this element is going to experience a velocity in x. That velocity in x, let us say, is x dot. It is experiencing a velocity in x, that is x dot. Apart from that, since this is a 2-degree freedom of system, that means this rod over here can rotate, it can swirl about this particular point. Therefore, there is a possibility of angular velocity. Let us say that angular velocity is represented by theta dot. Now, this angular velocity is going to give it a tangential velocity. The tangential velocity is supposed to be equal to how much? Radius multiplied to theta dot. So, therefore, let us say it is having a tangential velocity vector in this direction, which is inclined at an angle theta with respect to horizontal. Why theta with respect to horizontal? Imagine if the rod was vertical. If the rod was vertical, then it is going to be exactly horizontal. The velocity tangential is horizontal. If I incline the rod by an angle theta, even the velocity has to get inclined by angle theta with respect to horizontal. Therefore, angle theta. How much is this velocity equal to? Now, this you have to find out. It is radius multiplied to angular velocity, which is equal to y multiplied to theta dot. Y multiplied to theta dot. Now I can say the net velocity in x-axis, for this differential element is equal to how much? It is equal to x dot plus component. What is the component of this in the horizontal? It is equal to y theta dot into cos theta. Y theta dot into cos theta. And the component in the vertical, okay, there is no contribution in the vertical from here, only contribution from here. So Vy is equal to how much? Vy over here is equal to y theta dot into sine theta. Okay, pause the video over here for a moment. Please try to understand that there are two velocities, and the combination of these two velocities are creating a component in x and a component over here in y. These are the components I'm having. Now, let us move further. Now, I'm going to look for kinetic energy of the rod. Kinetic energy of the rod. Kinetic energy of the rod is equal to how much? This is the question I'm having right now. First of all, I'll start for a differential element. I realize that for every differential element, the value of y differs. Therefore, I have to talk for a differential element, and then I have to integrate it over the entire length. Okay, let us say the differential kinetic energy for rod is equal to half into mass, let us say is dm, into its velocity square. Now, what is the value of dm over here? Differential mass is equal to how much? You can think logically. Dekhiye, for the entire length, the mass is m. For a differential portion, it will be equal to how much? M divided by b multiplied to dy. So, I am going to have differential mass is equal to m divided by b is the intensity of mass per unit length multiplied to my small length, which is equal to dy. ठीक है. Now, what is this v square over here? ये v square क्या है? How much is v square? V square basically is a combination of vx square plus vy square. Okay, because v is having two components, na? Vx and vy. Therefore, vx square plus vy square. Acha, what is vx? That is what I have discussed some time back. The value of vx was equal to x dot plus you are having y theta dot cos theta. This was Vx. So let me square this up. Plus Vy is equal to how much? Vy is equal to y theta dot into sine theta square into sine theta square. If you calculate this value, how much is it going to be? Okay, x dot square plus y square theta dot square cos square theta. One more term will come. I'm writing it down. You will know why I'm writing it down. That term is 2 into x dot into y theta dot cos theta. Okay, I have opened up this entire thing. I have this thing now. I'm writing it beside over here. You'll know why. And that is y square theta dot square sine square theta. Sine square theta. Now please visualize this thing, or please look at this thing. You are having y square theta dot square cos square theta sine square theta. That means if I club this entire thing, I'm going to have only y square theta dot square. Therefore, the value of v square has to be equal to how much? The value of v square has to be equal to x dot square plus this entire thing is equal to y square theta dot square plus 2x dot y theta dot cos theta. Pause the video for a moment and understand this velocity square here. Once you have got the value of velocity square, all you have to do is push this velocity square into this equation and integrate. Let us see what that will yield. So I'm going to have, one moment please, yeah, half dm into v square. Once again, half dm into v square is equal to half of dm. I have mentioned it to you. It is very simple. Intensity of mass per unit length likhenge aap. Then after that you are going to write dy. That is a small length I'm having. V square, I'll have to look in the previous slide. X dot square, y square, theta dot square. X dot square, y square, theta dot square plus 2x dot y theta dot cos theta. 2x dot y theta dot cos theta. This is the value. If I integrate this, I'm going to have how much value? I'm going to have half m by b is common. Integral of x dot square plus y square theta dot square plus 2x dot y theta dot cos theta times dy. And where is my y ranging from? It is ranging from its 0 till b. Now this should be easy for you. I'm straight away writing the values. It is going to be x dot square b plus y square into dy is y square dy integral y cube by 3, therefore b cube by 3. So b cube by 3 times theta dot square plus 2x dot into y square by 2. Y square by 2 will give me b square by 2. Theta dot cos theta. Theta dot cos theta. So if this is going to be equal to half small m into x dot square plus 1 by 6 small m 1 by 6 small m into b square theta dot square plus 1 by 2 1 by 2 b cancels off, so I'm having over here m into x dot and a b multiplied to theta dot cos theta. This is the kinetic energy of the rod. So if I look for L, the value of L, which is equal to kinetic energy minus potential energy. Kinetic energy I was already having half capital M into x dot square. So I'm having half capital M plus small m into x dot square plus 1 by 6 m into b square into theta dot square plus 1 by 2 into m x dot b theta dot into cos theta minus potential energy, so minus half kx square, which is for half kx, not kx square, it is half kx actually, I'm sorry, half kx and potential energy of the rod was negative, therefore I'll have a positive over here, that is m into g into b by 2 times cos theta. This would be the answer to the question. Let us see where this answer is. If you look over here, F is not coming, that is wrong. This again is wrong. This again is wrong. He has neglected one point over here. This option C would be the correct answer. The answer to the question is option C. Okay. Now in this question, the difficult part was to identify the kinetic energy of the rod. Okay. Again, I'm mentioning the critical point over here is you have to realize that this rod is having two velocities. One is a linear velocity just due to the motion of this block. Along with the block, the rod is moving linearly. Apart from that, since there is a chance of this rod to rotate about point P, there is going to be a tangential velocity also present. That tangential velocity and this velocity combined vectorially should give you Vx and Vy. I hope this answers the question. The second question to have appeared in this examination was a fairly simple statics question. The question says, two smooth identical spheres, each of radius 125 mm and weight 100 newtons, rest in a horizontal channel having vertical walls. The distance between the walls of the channel is equal to 400 mm indicated. The reaction at the point of contact between two spheres in newtons rounded off to 1 decimal place is how much? So at this particular point, what is the reaction is asking. Okay. Now this question emphasizes the importance of geometry in statics. If you are good with geometry, if you are good with aptitude, then you can solve this question easily. Right? Let us see where geometry plays an important role over here. You see, when I'm going to draw the free body diagram of one of these spheres, in that free body diagram, the angles are going to be important. And to identify those angles, geometry is important. Let us see how. He has mentioned already that the distance between these two vertical walls is 400 mm. And the radius over here of each of these things is equal to how much? 125. So let us say that 125 is removed, 125 is removed from 400. Then what is left in between? the span left in between over here is going to be equal to 400 minus 125 minus 125, and that is 150. So this is equal to how much? It is equal to 150 units. Okay. Next, I'm having this angle over here. Let us see this angle over here. If you complete this triangle, okay, let me show you the triangle now. The triangle is something like this. The triangle is something like this. I have over here the base as 150 mm. And what about the hypotenuse? Hypotenuse is the radius of this sphere and radius of this sphere combined, which is equal to 125 and 125. That is equal to 250 mm. 250 mm. And let us say this angle over here is some angle theta. This angle is some angle theta. So the value of a sine theta in this case, if you calculate this is very simple. Okay, these are probably the most common angles which appear in our gate examinations for mechanics. Sine theta over here is equal to 4 by 5 and cos theta is equal to 3 by 5. Cos theta is equal to 3 by 5. Now what I'm going to do is I'm going to draw the free body diagram of this sphere and I'm going to apply Lami's on this. Okay, so if I have free body diagram of this sphere, let us say this is the sphere I'm having. First thing, the weight is going to fall down. The weight is coming down. This is the weight. Next, I'm having a normal from this wall. Let us say that normal from the wall. And I'm having a normal which is at the contact, is it not? He's asking me at the contact, right? So I have a normal at the contact. Normal at the contact. And this angle over here is equal to theta. This angle over here is equal to theta. My aim is only to find out the value of normal at the contact. Okay. For that reason, what I'm going to do is I won't apply Lami's. There's a very simple way over here. Sigma Fy equal to 0 should suffice. Is it not? Should be sufficient. Sigma Fy equal to 0 should be sufficient over here. So what have I got? I have, let us say, if I write for this sigma Fy equal to 0, what do I have? I have the component of NC in the vertical, that is equal to NC sine theta. Okay, NC sine theta minus W is equal to 0, which implies the value of NC is equal to W upon sine theta. That is equal to. Now let us look at what is the value of W. W is 100 newtons. Sine theta is equal to 4 by 5. So 100 divided by 4 by 5. So the value of contact normal is equal to 125 newtons. Okay, very simple question. This is the answer to the question. Thank you.